In this video, we'll cover just a couple of vocab words, dilution and stock solutions. By the end, we should be able to calculate the volume of concentrated solutions needed to prepare a dilute solution. We'll also be able to calculate the final concentration of a solution that was diluted with water. I have a situation here. So there's this drink that you can mix up called Tang. It's pretty popular when I was younger. It's very bad for you though in retrospect. Anyway, I make a cup of Tang. You can see my fantastic mixture of Tang with the image on the left. I make a cup of Tang following the recipe on the container, but it's too sweet. What do I do? Do I just pour it down the drain and remake it? No, I could just add more water to dilute it. You know that. So let's just formally define this word. Dilution is the process of adding water to a solution to make it less concentrated. So we have a container of solution here with these jumbo-looking solute molecules dissolved in water. Now look closely. What happens when we dilute it with water? What's different about this? It looks like only the amount of water changed. This leads to a key idea. When diluting a solution, the amount of solute stays the same as water is added. Only the amount of solvent is changing. There's this neat little equation that exemplifies this idea. M1 times V1 equals M2 times V2. So there's one that represents the molarity and volume before diluting happens. The twos, they represent the molarity and volume after diluting. I'll add this to the definitions you should try to remember. So the reason this equation works is because if we break it down, it'll demonstrate how the amount of solute molecules should stay the same before and after dilution. M1 is molarity, which can be represented by moles over liters. V1 represents volume, which can be represented by liters. Liters and liters cancel out. The M2 is the same thing on the right side, and the V2 is the same thing. Liters and liters cancels out here too. I'll say it again. The amount of solute molecules should stay the same before and after a dilution. This is clearly represented in this dilution equation because you can see moles equals moles in the end. Okay, we'll use this equation now to see two different use cases. In this example, how many milliliters of a 4 molar sodium hydroxide solution is needed to make 500 milliliters of a 1 molar sodium hydroxide solution? So basically, we have a concentrated 4 molar stock solution. We need to figure out how much of it we need, combined with water, to prepare 500 milliliters of a less concentrated solution. By the way, a stock solution is just a highly concentrated solution we use to prepare solutions from. So we start with writing the dilution equation, and we try to figure out what we're trying to solve for here. According to this problem, we want to solve for how many milliliters of a 4 molar solution we need. Okay. We're also given that we want to make 500 milliliters of a less concentrated 1 molar solution. So we are trying to figure out a volume, and it's a more concentrated volume. So this is before a dilution. So we're trying to solve for V1 here. And how about we start labeling the rest of the things that we are given. So if we're trying to solve for V1, then that means this 4 molar right here is M1. It's the more concentrated solution. That means the 1 molar is M2, and we want to make 500 milliliters of it. So that means that's our second volume. Okay, and we're essentially just going to be plugging these numbers in. Before we plug it in, I always like to isolate what we're trying to solve for first. So in this equation that we already have, to isolate V1, we have to get rid of M1. So we divide both sides by M1. Now on the left-hand side, M1 and M1 cancels out. On the right-hand side, none of these cancel out. They're not exactly the same. So you can see that now V1 is isolated, and V1 is what we want to solve for. V1 is equal to M2 times V2 divided by M1. So we just plug in these numbers. V1 is equal to M2 times V2 divided by M1. And you can see there's going to be a unit that cancels out here. Molarity and molarity cancel out here. We're going to be left with milliliters, which makes sense because we're trying to solve for volume here. So we just type this in a calculator. We have 1 times 500 divided by 4. If you type this in a calculator, this is what you'll get, 125 milliliters. And that's our answer. So to answer this question, we need 125 milliliters of that concentrated 4 molar sodium hydroxide solution in order to make a lot, 500 milliliters of a 1 molar NaOH solution. In this example, you're handed 12.5 milliliters of a 6 molar solution of hydrochloric acid. You're told to dilute it with water until there's 1,500 milliliters of solution. What's the final concentration of the acid? Okay, so normally we don't work with hydrochloric acid that is like 6 molar. That is super concentrated. So we're diluting it here until there's a 1,500 milliliter solution. So what's the final concentration of this acid? We're going to start by writing down the dilution equation again. And in this problem, we're trying to solve for the final concentration. So the second molarity is what we're trying to solve for. Okay. What do we have here? I'm going to figure out what the rest of these numbers are going to be. So you're handed 12.5 milliliters of a 6 molar solution of HCl. So that's super concentrated. That's our first concentration. And that's our first volume, okay, before the dilution happens. And we're told to dilute it until there's 1,500 milliliters of it. So that's our second volume. And the final concentration, we already know that's M2, okay? Now, we can start plugging in those 3 numbers that are given in the problem, but I like to isolate my variable first in the equation. So I need to get M2 by itself. To get M2 by itself, we want to divide both sides by V2 to get rid of V2. And if we do this, V2 and V2 will cross out on the right-hand side of the equation. And now you'll see that M2 is by itself. M2 is equal to M1 times V1 divided by V2. So this will help us solve for our final concentration. So now we just follow that equation. Now M1 is 6 molars. We're multiplying it by V1, which is 12.5 milliliters. And we're going to divide it by V2. V2 is 1,500 milliliters. If you have this all plugged in, the unit that cancels out is milliliters and milliliters. We're left with a concentration unit, molarity, and that's what we want to solve for. So we just type this in a calculator. It's that simple. You take 6 and you multiply it by 12.5, then you divide it by 1,500. You grab a calculator. And if you type this in, you should get 0.05 molar. All right. So the final concentration, if you add a bunch of water until it's 1,500 milliliters, it's 0.05 molar. All right. I have 2 practice problems right here. I want you to try on your own. So pause the video, and then in about 5 seconds, I'll show you the answer and the work for it. And there are the answers with their work. So if you didn't get the right answer, take a look at my work and see if you can try to piece it together. I have just 1 practice for you to try after this, and let's just see if you are able to do it. I'll give you some feedback.